Hello everyone. Welcome to Energy Conversion 2 class. We are doing with chapter 2, Alternators Synchronization. So, first of all, going towards the definition. In an alternating current electric power system, synchronization is the process of matching the speed and frequency of the generator or other source to a running network. Now, an AC generator cannot deliver power to an electrical grid unless it is running at the same frequency as the network. We have already studied in the parallel operating alternators the phase sequence, the voltage, the phase angle and the frequency. These four parameters are to be identical with the incoming the bus bar, so that parallel operation can be done, or we can say synchronization can be done. If two segments of a grid are disconnected, they cannot exchange AC power again until they are brought back into exact synchronization. So, synchronization play a very important role in parallel operation of alternators. Now we will discuss the techniques for synchronization. There are different techniques being available for the synchronization of alternators. The primary purpose of these techniques is to check all four conditions discussed earlier. The common methods used for synchronization are: number 1, 3 dark lamp method, 2 bright 1 dark lamp method, third one is synchroscope method. So this is 3 dark lamps method. Here we can see generator 1 is connected to the load. Here we can see generator 2 is connected in parallel to the common bus bar here. And here is the voltmeter. Here is another voltmeter. This will show voltage of this generator, the common bus bar, and this voltmeter will show the voltage reading of the incoming machine. And here we can see L1, L2, L3. These are synchronizing lamps, and a synchronizing switch is there. It can be S or S1. So, through the help of the switch and 3 different synchronizing lamps, the incoming machine is getting connected in parallel with the common bus bar. And here is the load which is to be supplied by the parallel generator set. So now the figure shows the circuit for bright lamp method used to synchronize the alternators. Assume that alternator is connected to the load supplying rated voltage and frequency to it. Now the alternator 2 is to be connected in parallel with the alternator 1, the previous alternator. 3 lamps, each of which is rated for alternator terminal voltage. They are connected across the switches of the alternator 2. From the figure, it is clear that the moment when all the conditions of parallel operation are satisfied, the lamps should be more or less dark. To synchronize the alternator 2 with the bus bar, the prime mover of the alternator 2 is driven at a close to the synchronous speed decided by the bus bar frequency itself and the number of pole of the alternator. Now, the field current of the generator 2 is increased till the voltage across the machine terminals is equal to the bus bar voltage, which can be observed by the voltmeter readings. If lamps go on and off concurrently, indicating that the phase sequence of alternator 2 exactly matches with the bus bar. On the other hand, if they on and off one after another, it resembles the incorrect phase sequence. So, accordingly, by changing the connections of any 2 leads of alternator 2 after shutting down the machine, the phase sequence can be changed. Depending on the frequency difference between alternator 2 voltage and bus bar voltage, on and off rate of these lamps is decided. Hence, the rate of flickering has to be reduced to match the frequency. Remember this. And this is possible by adjusting the speed of alternator by its prime mover control. The speed of the alternator can be adjusted. When all these parameters are set, the lamps become dark and then the synchronizing switch can be closed to synchronize the alternator 2 with alternator 1. The main disadvantage of this method is that rate of flickering only indicates the difference between the alternator 2 and the bus bar. But the information of alternator frequency in relation to bus bar frequency is not available in this method. We can say, suppose if the bus bar frequency is 50 Hz, the rate of flickering of lamp is same when frequency of the alternator is either 51 or 49, any frequency nearer to 50 Hz, as the difference in these two cases is 1 Hz only. So now coming to the next method, 2 bright and 1 dark lamp method. Here only the difference is 2 dark lamps are taken and 2 bright lamps are taken and 1 dark lamp is taken. By seeing the connection for this method, we can say that it is useful in finding whether an alternator frequency is lower or higher than the bus bar frequency. Here, the lamp L2 is connected across the pole in the middle line of synchronizing switch as similar to the dark lamp method, whereas the lamps L1 and L3 are connected in a transposed manner. The voltage condition checking is similar to the previous method, and after it, the lamps glow bright and dark one after one. The lower or higher value of alternator frequency in comparison with bus bar frequency is determined by the sequence in which the lamps become dark and bright. Okay. The sequence of becoming bright and dark L1, L2, L3. This sequence indicates the incoming generator frequency is higher than the bus bar frequency. Hence, the alternator speed has to be reduced by prime mover control till the flickering rate is brought down to a small. On the other hand, the sequence flickering L1, L3, L2 indicates that incoming alternator frequency is less than that of the bus bar frequency. Hence, the speed of the alternator is increased by the prime mover till the rate of flickering is brought down to as small as possible. The synchronizing switch is then closed, and the instant when lamps L1 and L3 are equally bright and the lamp L2 is dark. The disadvantage of this method is that the correctness of phase sequence cannot be checked very accurately. That is why this is very rarely used. However, this requirement is necessary for permanently connected alternators, where checking of phase sequence is enough to carry out the first time of operation alone. Now, we are at synchroscope method. Similarly, generator 1, generator 2 is there, and they are connected with a synchronizing switch to the running alternator. Voltmeters are also there, and here we can see the synchroscope. Now, it is similar to the 2 bright and 1 dark lamp method and indicates whether the alternator frequency is higher or lower than the bus bar frequency. A synchroscope is used for better accuracy of synchronization, and it consists of 2 pairs of terminals. One pair of terminals marked as existing has to be connected across the bus bar terminals or to the existing alternator and other pair terminal is marked incoming. Has to be connected across the terminals of incoming alternator. The synchroscope has a circular dial over which a pointer is hinged that is capable of rotating in clockwise and anti-clockwise directions. After the voltage condition is checked, the operator has to check the synchroscope. The rate at which pointer rotates indicates the difference of frequency between the incoming alternator and the bus bar. Also, the direction to which the pointer rotates to either fast or slow gives the information whether the incoming alternator frequency is higher or lower than the bus bar frequency, and hence the pointer moves either slow or fast, we can say. Now, the appropriate correction has to be made to control the speed of the alternator so as to bring the rate of rotation of pointer as small as possible. So, therefore, synchroscope along with voltmeters are enough for synchronization process. However, in most of the cases, a set of lights along with synchroscope is used as a double check system. These are the methods of synchronizing the generators. This process must be done very carefully to prevent the disturbances in the power system as well as to avoid a serious damage to the machine. Only 3 lamps method are not perfect today due to less accuracy and manual operation. These processes need a skilled and experienced person to handle the equipment while synchronizing. In most cases, synchroscope method with set of lamps is used as mentioned. Modern synchronization equipments automate the whole synchronization process with the use of microprocessor-based system that avoids manual lamps and synchroscope observation, and these methods are very much easier to manage and more reliable. That is why today we are going forward for using these microprocessors. Thank you.